Simon and the work, Simon, who's her robot, which she's going to talk about a lot this evening. So yeah, with that, Nick, all yours.
Ignore. Sorry.
Thank you so much for having me. I'm really pleased to be here.
Thank you. It needs to be higher.
So, as Una said, I'm an artist and a designer and a teacher and work with technology and music in a variety of different ways. And actually, part of my background, which is oddly a little bit more probably connected to anthropology, is I do a lot of work with oral histories and worked for years with the StoryCorps project. But what I'll be talking about is sort of a different side of my creative world and maybe less directly, obviously connected to anthropology, but maybe we can suss out some interesting connections. So I'm going to start off by, I'd like to show an example of some of the sound installation work that I do. And as I said, I work with musical robotics. I've been building musical robots in various forms for about 10 years. And this is a recent piece that was at the Palais de Tokyo in Paris, which is a large contemporary art center in central Paris, and a collaborative piece with a number of different artists, including a crew of people who build structures out of scavenged architecture, another roboticist, and some light sculptors, a whole variety of people to kind of create this large piece called Concert Hall, which I'll show you the video and then talk a little bit about it. So it's a longer song, obviously, and thank you. One thing is the robot's really going to be good. But so this installation was all about creating this immersive sound experience, and we had this structure that we called the concert hall, and it was filled on all sides with these little sound-making devices that ranged from actual instruments, electric pianos, xylophones, to a series of objects that were sort of pressed into service as noisemakers using robotic actuators. And it performed an hour-long program of original music that I wrote along with a French composer named Yulman Carla, who's a wonderful pop musician who does work with Stereolab and other interesting projects there. And so, as you can hear, it's sort of an experimental approach to making what we hope is very accessible, friendly music. And beyond that, you notice another component of it is it's sort of a way of working that I've come to call doing a song installation, and it often combines for me sort of the disembodied voices, recorded voices, in some cases being transmitted over radios, combined with these musical robotics, and sort of beyond just the kind of joyful experience of it and creating this immersive sound experience. So we have actuators hanging from the ceiling and surrounding the audience as they walk through the space. For me, it's also about sort of blurring the line between what is human presence and what is human expression in experiencing the piece. So the most literal embodiment of a human is disembodied, these voices floating in from the walls. And then the robots are perhaps the most lively or present component. And this is really, this is going to be the way that I like to think about the music I make. Now, I also use these setups for performance. This is an example of a performance in Warsaw where I'm actually wearing a helmet with mechanical actuators and there are piano wires stretching up to the ceiling so that it's an automated instrument that I can tune by moving my head as we play, and use it as a recording project as well. And I first came to start working with these musical robots after I recorded an album of music just working with a laptop. And this is something that in the late 90s, early 2000s, a great number of musicians were suddenly floored by all the possibilities that existed for digital production platforms. So suddenly, what you had to have a fortune to buy in a recording studio before was all available right on your laptop. And with that came incredible possibilities in terms of the precision and control you have and the number of sounds that you had access to just by downloading different instruments, but also a set of problems. So my experience, after recording this music just on the computer was I had no desire to perform live with it or to otherwise share it beyond just being a recording. So this is an image of a popular folk performer, Girl Talk, doing his live show behind a laptop, and he's a great dancer. But there's really not a lot of connection between the creative musical process or what's going on with the music and what's demonstrably happening on stage. So for me, working with musical robots became a way to keep the advantages of working with the digital production platform, all the precision and control and wonderful editing possibilities, while porting it out into the real world. And simultaneously, I would say also having something that has a bit more creative resistance. So instead of spending hours and hours trying out different samples and synthesized sounds for the music you're making, you're dealing with actual physical objects that have a limited range of possibilities, and you have to become creative in order to get the sounds you want out of them. And really, the feeling that I was hoping to evoke in kind of moving this direction too, I think is somewhat akin to parlor music. The experience of music for many people for centuries before recording technology was a very social one and a very small scale one of not necessarily having the resources to go see a live performance in a large concert hall, but having family members who know how to play music and perhaps sitting around a piano and singing with them or joining in. And so in creating these installations with robotics, in some ways I'm trying to create that more human scale experience. Perhaps ironically, making it a more human and kind of explorable experience for people by removing humans, by having actual machines that they can get up close to explore. This is another example of a song installation that I did in 2008. In this case, the vocals were coming through those antique radio horn speakers. And so sometimes I use these musical robotics as well for interactive projects. So sort of a hybrid between somebody performing a piece of music and there being an automated composition that's playing. So this is a piece called Animal Magnetizer that uses spatial sensing to allow members of the audience to control which elements of the installation are triggered. So again, these are physical objects being controlled by a computer, and then as people hover their hands over each one, they become activated. And so they're controlling what's playing, but there's a kind of pre-programmed pattern that they're controlling. So here's a video of that. I'm interested in is as much the kind of social component of it, that for actually all of it to be triggered, you have to have multiple people kind of acting in concert. And it's a way of, many people who are not musicians, I think, enjoy it because it's a way of having control over musical playback and kind of collaborating with somebody on a musical experience without actually having to, of course, learn an instrument. This is another project that uses sound actuation as sort of a creative tool, physical sound actuation. It's a data representation piece that I did at the New York Hall of Science called New York City Immigration Song. It's a 12-foot wide wall panel, and it has piano wires stretched across it, going from various points of origin to a central node in New York City. So each piano wire represents a different path of immigration. And it uses the data set of census data of New York's population to play through, you could call it a composition. And so the distance of that path of immigration translates into a musical pitch. And then the duration that each of those notes is held is corresponding to the number of people in each census year. So here's a brief documentation of that piece. So, in this case, a very different use of robotic sound making as a way of sort of giving voice to a data set and allowing people to experience that data as time-based media. And that the snare drum that was playing there too, a big part of this project was also doing research and kind of putting together that data set I wanted to use. And of course, one of the realities of working with census data is there are a lot of gaps in it. And so that snare hit was representative of any gaps in the data. So each time I got to a country for a census year for which there was not a data point, using that robotic data to represent that. So I'll take a step back here, about 200 years back. As Uma mentioned, I teach a class at ITP, and if you're not familiar with NYU's Interactive Telecommunications program, it's a really fabulous place for anybody who has an interest in sort of the overlap of technology and the social. So the class I teach is about automata, and it's a production class where students are working with automation technologies for creative purposes. And one of the things that we do is take a look at historical automata and both their technical operation, but also the cultural context and kind of why they existed and why they were made and the areas in which they were made. So this is an example from 1784 of a musical automata that it's a dulcimer player, and it was actually built for Marie Antoinette. This was the scale of production that was required at the time. It was something equivalent perhaps to a Department of Defense contract in order to have this type of technology available. And I'll show an example of it and then maybe talk a little bit about it. So it's obviously absolutely astonishing and very beautiful. One thing that I find interesting about it, though, is we see this, and I think we see it as something that's somewhat whimsical and really something for entertainment and for delight, the province of entertaining royalty. At the time, though, in the 18th century, these automation projects were often a way of exploring, is a way of doing scientific inquiry not only in terms of mechanical engineering, but also of exploring human biology. The famous example of this is Wilkinson's defecating duck, which was an automaton that would accept grains of wheat and then, through a digestive process that was mechanically designed, poop it out. There's actually some controversy as to whether that's actually what it was doing. But this is just to make the point that that at the time, this was considered to be a way of exploring the function of the human body. There was a very kind of mechanistic view of how humans worked. And this may seem like an unusual point of view for us at this point. But there are some scholars who have made some convincing arguments. Jessica Riskin wrote a great article about this, that we are sort of returning to this same point of view, particularly in our pursuit of artificial intelligence and looking at the ability to recreate essentially what we're deeming the human cognitive system in an artificial robot way as a way of exploring the human mind and understanding about that. And I think it's interesting and informative to think about how sort of the technology that we have available to us can become the metaphor through which we understand human beings and animals. Now, I'll take a step forward now and look at a very different example of the use of automation for musical purposes. This is the composer Yulman Carla, who was famous for writing pieces of music specifically for the player piano. And Nancaro came to the player piano as a medium in part because of his frustration with working with human performers, both in terms of their technical limitations, he was writing scores that they couldn't play, but also the social difficulties of being a composer and having to have human musicians play your work. So he had a device fabricated that allowed him to very directly compose for piano rolls, essentially programming a binary device as creative coders and hardware hackers do these days. So this is an early example of his studies. It's one of a series that he called the Boogie Woogie studies, so it's perhaps one of his more accessible ones. Extremes of what it can mean to make music with machines, perhaps, and I'm not necessarily convinced that having something that looks more like a human being and acts more like a human being playing a musical instrument actually is the more expressive option. I mean, it's a tremendous machine, and the series of cams that govern not only the movement of the arms to play the different notes of the dulcimer, but also control the automaton's head to really give it a very lifelike presence. Particularly for the time, something that would feel quite astonishing. But for me, in some ways, Yulman Carla tapping into the player piano for exactly what it's good for and sort of unleashing his creative will on it in this incredible way, sort of exploding a boogie-woogie piano piece in a very abstract way, is just as exciting, if not more so, a creative act in terms of how to harness the creative potential of a machine. I'll finish just by talking about my most recent project that I've been sort of devoting attention to, and that is developing the modules that I use for my own musical installations into a product, into a toolkit for other musicians to use. Because as I said, making that transition for me of working with a computer to being able to use that computer to control physical objects was a very exciting one, and kind of opened up a lot of different possibilities for how I thought about presenting music and how I thought about actually writing the music that was going to be presented. And so I'm very excited to develop this kit called Bricolo, which is a modular mechanical music system. We have a series of fairly simple actuators, like for instance this drum striker that mounts onto a microphone stand and then can be easily positioned on a drum or any other object you want. Or this module, which is a small actuator that can be triggered very rapidly, and anything you put on it can become a sound source, including both percussive and melodic. And I'll close with, I'll actually just play a demo video, so it'll just be me speaking via technology. The Bricolo mechanical music system makes it easy for musicians, composers, producers, and DJs to incorporate robots into their setups. It gives you the control and precision of digital production platforms while letting you explore the sounds of the world around you. Setting up Bricolo is easy. A control box contains the Arduino-based electronics. Just plug in power and MIDI signal, patch in the modules you'd like to use, and start experimenting with sound from different objects. It's easy to try different sounds while playing a sequence, just like changing settings on a synthesizer or sampler. Physical manipulation of objects can be a part of your performance. Bricolo takes a standard MIDI input, making it compatible with a wide variety of music production software, sequencers, and controllers. The ThinkSynth module goes beyond percussion sounds and lets you play melodies and bass lines on physical objects. Changing the properties of an object is like dialing in new settings on a filter. So that's a demo of this toolkit that I'm trying to put together as a way of offering the option of working with musical robotics to a broad range of musicians, anybody who's currently making music with a computer. And I'm very excited to be producing sort of the first batch of them right now for a fairly diverse group of musicians, ranging from touring pop musicians to techno musicians to experimental electroacoustic composers. And so I'm very excited about seeing what is produced from distributing these modules elsewhere, and just in general about the continuing possibilities for developing this system and kind of democratizing musical robots. Thanks very much.
Thank you. Thank you. Nick, that was amazing. So as was mentioned earlier, my name is Carla, and I am a designer. My focus has always been the physical object that has some kind of digital behavior, programmed behavior. I have a background in mechanical engineering and industrial design, but somewhere along the way became very seduced by digital tools. For the last 5 years, I was full-time at a firm that's called Smart Design. Many of you may have some of the objects designed by Smart in your home. They're well known for the flip camera as well as the OXO line of kitchen tools, as well as a lot of things for HP. So things that I tended to work on would be printer devices or appliances for some of the large appliance manufacturers, car interiors, things like that. And this past January, I wrote a piece for the Sunday Review about robotics and about how I see robotics starting to bring emotion into our everyday objects. I think I'll just show that. I'm Carla, and this is a day in the near future. Another Monday morning. My lamp has just gone from dim to bright. I try to turn over, but it rotates to follow me. I stumble into the bathroom. I brush one side for a while. Zzz, the toothbrush vibrates, so I know it's time to switch to the other side. Now I'm really awake. The bathroom mirror says, "Nice job on your weight, but your heart rate is a little higher than yesterday." As I head to work, my bike confirms my appointment. On our way to Ted's office? Yes. When it's time to turn, my handlebar vibrates and my jacket lights up to signal a left turn. At the meeting, I draw some sketches with my memory pen. When we're done, it emails my notes to my colleagues. Back at home, the door recognizes me. The lights turn on, the stereo starts playing, and my 3D printer whistles. The Lefty toy I downloaded earlier for Rue is ready. Now it's time for dinner. My countertop sous chef checks my favorite recipes and wirelessly queries the fridge. We have ingredients to make roasted salmon or pumpkin risotto. Thanks to the salmon, I say. After dinner, my partner Mike and I bring our dishes to the sink. I say, "Okay, start cleaning." And the faucet squirts soap and water at the dishes while we head off to relax with our favorite movie, Back to the Future. So I'm I need to work into my bio somewhere that the New York Times let me do ridiculous robot voices. But my interest in this is really, as a designer, even objects that don't have electronics in them are expressive and have some kind of personality, whether we like it or not. We can look at an object and look at the material that it's made and some of the details of the form and say that it's cute or it's aggressive. Or it's shy. And so when I was at Georgia Tech as a faculty member, I became really fascinated with what was happening in a lab that's called the Socially Intelligent Machines Lab. And while I was there, I was approached by Dr. Andrea Tomaz, who leads the Socially Intelligent Machines Lab, because she was starting a new robot project, and she was looking for a designer to work with. And the project is called Simon. And she knew that she wanted to work with an industrial designer, and she also knew that she wanted to kind of balance the expectations that people had between it being an entity that you could approach and speak to as if it were a human being, and it also being a machine. The entire idea behind the lab is really to study the ways that we can interact with machines in as intuitive a way as possible. So instead of having to learn a mouse and keyboard, can I just approach an object? Can I talk to it? Can I gesture at it? can I not have to learn the interface, so to speak? And for me, as a designer, this is a really fascinating place, right? What is that line between the automata that we looked at, that is this sort of exaggeration of body, and the machine that, you know, is all kind of guts? Like, what is the balance in between there? So this has been one of the most exciting projects of my career. The starting point with this was Dr. Tamaz was a PhD student on the Kismet project, which was at MIT. And actually, Kismet was the first project that led to Leonardo. She was a PhD student on Leonardo. So this is Leonardo. And Leonardo is quite remarkable as a robot. And it's one of the first social robots, where, again, you can speak to it, it will gesture to you, it blinks, it will wave, it will recognize you. And this is a remarkable machine. If you have ever met it up close, it actually has leather lips and yak hair and these eyelashes, and the fingers are amazing. And what happened with this project, though, is that it was falling into what many of you may be familiar with, uncanny valley. And it seemed too lifelike, and children ran screaming from the room. So Dr. Tamaz knew that she had a few observations and wanted to do something like Leonardo, but not have it be so much of a real creature. Leonardo had been developed by Will Vinton Studios. So some of her learnings were that she knew that eyes were going to be very important. She knew that it was really not going to be a human clone. It was not going to be human-like. It was somewhat creature-like, somewhere in between. Hyper-realism could have a frightening effect. We wanted to balance machine aesthetics and human forms to help avoid the uncanny valley. And while Leonardo had over 30 degrees of freedom in the head and face, ears were going to be a really important feature, as they were most often used for emotional and nonverbal expression. And a desirable feature set was going to be a rotating and pivoting head, movable eyes, top and bottom lids, eyebrows, a mouth, some expressive ear feature. And you know, some of the initial constraints for this particular robot was going to be non-ambulatory. So it was actually a top upper torso humanoid robot. There was a body that was had already been designed by Mecha Robotics, which is in the Bay Area. It should appear young to reinforce its role as a learner and set expectations that it's learning. So this was really the starting point for the robot. We knew the size of the camera, we knew the elements of the torso. The SolidWorks file essentially looked like this, and the rest was kind of a blank slate. So the first thing we wanted to do was establish a little bit of a vocabulary. So I think about design sometimes like being an optometrist, where you're just kind of fine-tuning the vision, little by little. Is it better now or now? More like this or more like this? And so what I did is I did a survey of all the kind of popular robots, either fictional or real, toy or research robots, and started to hone down on an aesthetic. And we decided that this kind of friendly doll aesthetic, which you see in the bottom there, there's some Sony partner robots, Osimo is in there, many of you are familiar with, and that was going to be our target. And I was relying a lot on Andrea as somebody who had years of experience in this, as well as speaking to some of the other PhD candidates on campus, and we settled on this. So the friendly doll aesthetic is figure-like impression, non-threatening forms, affordances that might suggest multiple functions. Maybe it's an ear, maybe it's an antenna. Simplified forms that were not overly like an anatomy, that started to be leaning towards a machine, and then collected some references. So the Sony partner robots were a great reference. This is a fictional robot that was created by a Drexel University student. We were really kind of trying to go for this young toddler, cute, but still a machine. So, Marvin is a really good example of that. Mega Man, Money, which isn't a robot at all. Toonami Tom, which used to be on the Cartoon Network, and developed some ideal characteristics that seem to flow among all of these. One is that the top of the head would have some kind of covering, and it would be a little ambiguous. Is it hair? Is it a helmet or a hat? Ears would be abstracted. We decided to really exaggerate the ear portion because we knew how important that was for communication. Eyes would be distinctive. Mouth and eyebrows were going to be used, although you see in the robot that we wound up with, it isn't actually there. And we were going for, again, these kind of childlike proportions in the body to the head and the head to the eye. And I also, as references, went outside the robotics world and looked a great deal at books about cartooning, certainly books about design, animation, and of course books about robotics. And then, started, my role in the team. So the core team was really Dr. Tamaz, who was leading all of the artificial intelligence work, Jonathan Holmes, who's a mechanical engineer on the project, and myself. So my role was really this creative direction, to say, should they have eyes or not? Are they ears? Are they not ears? So what I would do is I would go around and just, everything I saw would kind of remind me, like, what is this form? Is this, so things like, I would see this and I'd go, oh yeah, that's kind of like helmet, kind of hair, kind of, and then, I go to my friend's house and I can I take a picture of her baby? This is Gigi. I said, that's kind of perfect. And continuing to look at references, think about how these facial expressions are going to come about from our robot, then, start sketching what might the different head shapes be, showing them to Dr. Tamaz, showing them to some other folks on campus, eye size again, and placement, and then really started sketching. So, exploring this, how might we exaggerate ears, how might we have ears that are not ears, what is this kind of line between the machine and the robot, let's think about some different ear shapes, and then some, initial sketches. So these are some of the first sketches for the Simon robot. Again, not quite being a human, still sort of being a machine. This one gets a little bit more machine-like, where we're starting to really use speaker semantics for those ears, and really exaggerating this helmet characteristic. Some more sketches. I was really thinking a lot about the fact that it was an upper torso and didn't have legs, so could I abstract legs? I think what we wound up doing is ultimately it's actually used a lot sitting at a table and people approach that table. So here's some of those initial Illustrator sketches superimposed on the SolidWorks, trying to look at that. Here's my attempt to say, like, could we pretend that it's kneeling, have it somewhat be kneeling, and again trying to get closer to that balance between a creature and a machine, looking at head to body ratio, then getting into 3D for sketching, and modeling in Cinema 4D and Rhino, and then really starting to look at animations, and then really working with the team. So the eyes were really a constraint for the design because the cameras were very limited in size. So I think we had a 2-inch diameter and we couldn't go any smaller. So that really determined a lot of the other things because we kind of knew what we wanted the eye proportions to be in terms of the entire head. So if the eye proportions if the eye size are fixed, then that kind of sets up a lot of the other things. And of course there were a lot of iterations in all the forms. This is an exploration of what might be a covering for the neck. Here's an exploration of the ear, what the socket might be. And here we're getting actually closer to what the final Simon wound up looking like. And this was actually close to the final design. In this one, we started really doing a lot of animations where I could see the lips moving and I could see the eyes blinking and those ears moving up and down so that we could start making some decisions. And at that point, we were also 3D printing scaled down models. And, you know, again, showing them to some kids that were on campus, showing them to some of the other faculty members, and some of the other students, and getting feedback. We also were pretty excited about playing with something new. A lot of humanoid robots actually have slots where you have movable features. So I think the Nexi robot at MIT has a slot where the eyebrows, and we really wanted to try to avoid that. We felt that that was a big feature that kind of takes over the face. So we had started developing a slot system with magnets behind the shell where those eyes, so this is us kind of playing around with that. And this was me playing around with some of the, we knew that the mouth was going to have a couple of possibilities for motion. The two ends could move up and down, and the top and bottom could independently move up and down. So I was trying to explore what the range of expressions would be. And this is really just a printout with a piece of plexiglass on top of it with the magnet system. At the same time, we were looking towards doing body shells, which are still in the works. But this was a printout of what some of the body shells might be. And then, you know, here is when our final construction. So this was the day that all the parts turned up. Here you can see actually the tracks for the magnets. This was what the ear pod wound up looking like. And this was kind of a really exciting moment for me, being on a pioneering team. And one of the things about doing pioneering work is that you really are making it up as you go along, to be honest. And I remember having a meeting with Jonathan and Andrea one day and saying, you know, can we put LEDs in the ears? And it wasn't something that was part of the original design specs, but we said, yeah, I think the budget will allow that, and that doesn't take too much. And we didn't really know what it would be used for. And the first day that I actually saw the robot assembled and programmed, it was doing an activity where it could recognize color. And this moment was really remarkable to me because it really communicated so much. It made you feel like you knew what the robot was thinking. You could show it an object and then these ears would turn, like you would show it green and the ears would turn like green, and you go, oh, it saw it. And maybe it didn't know the word green, but you knew that something was going on in the brain, let's say. The head construction was incredibly complex. There were a couple of different mechanisms that were used and failed in terms of the neck and holding it up. Here it is. You can see some of the magnets on the shell there. And actually, in the final moments, the eyebrows and the mouth wound up not being used. Due to budgetary constraints, really, those motors dropped out. So me as a designer, I was always kind of saying, like, but we still should have something there. So I'll show you what a new iteration of it, how we dealt with that. But you know, this is what the final robot wound up looking like. We because of restrictions in motion, we decided to leave the body shells actually out of this version of the project. But this is one of the best portraits of Simon, actually, that there is, that the New York Times took as part of the piece. But this is what the final robot looks like. And some of the activities that it's been doing color recognition, we're starting to do object recognition. There are also a lot of explorations around the robot being able to recognize a person and keep that person's gaze or get a person's attention. Here's the robot picking up an object. It has pads in its hand, so it can know if there's an object being handed to it, and it will hold that object up to its eyes. Here's some of the different kinds of expressions. Being cool. Oh, come on, what happened? It didn't. Oh no, I'm getting the spinning thing. but what I want to show you next is a video of Simon in action. So what you're about to see is this routine that it goes through. So Simon can actually hear sentences and parse the sentence. So, and it has certain, ways that you should speak to him. You should say, Simon, take this, and Simon will hold out a hand and say, okay. And then it will automatically, when holding an object, hold it up to the cameras, and then you say, where does this go? And Simon will say, it goes in the red bin, or the green bin, or the blue bin, if it's learned that color before. If it's never seen the color before, it will say, not sure, I don't know, and it will do this kind of gesture. And it's pretty great. So here's a snapshot of Simon in one of the research sessions. And here's a video, and I apologize for the sound on this. It was taken at the Chi conference a couple of years ago. But this video will show you the routine of it learning the colors. So here, you say, Simon, take this, and Simon says, sure. Kind of tilts its head down. There you see the moment of recognition. You say, where does this go? And Simon says it goes in the red bin. And it will actually physically put it in the correct bin. Simon says not sure, and here he does a little gesture. This gesture's a little tame, but he's got some bigger gestures. Like there he just kind of did this. But it was reset in a later part of this demo. I think we can get the gesture. So here it was reset, and Simon says, I don't know. And there he goes. I don't know. Green. Teach me green. This Chi conference was the first time that I had seen it going through this routine, and I have to say it was a remarkable moment to have been part of the team of this creature being created, and really seeing it come to life. I mean, it did give me goosebumps. So now he knows, goes in the green bin. He's learned. So we've had some remarkable reactions. At this point, it's still being used in a lot of research studies and ongoing studies, and studies that are getting more and more sophisticated in terms of looking at the ways that humans might interact with a machine, how gesture might play a role in it, how language plays a role in it. Here's what some people said. I was surprised at first, but it made the interaction easier because I knew he knew some of what I was saying. What was amazing, his movements felt like there was something in their learning, and it wasn't just all motors. So there's this kind of suspension of disbelief that happens. Nova calls it Simon, the kinder, gentler robot with a face that's easy to love. Engadget called him super cute, so as the designer, I was, really proud of that. And it's gotten really great press. This was the cover of Technology Review. This was another piece in the science section of the New York Times from a couple of years ago. There was a Nova piece. I wrote a piece where I talked about how